Here we're given a particular chemical formula, in this case hydrogen cyanide, and we want to determine what the Lewis structure is. Looking at the total number of valence electrons, in this case hydrogen will have 1 valence electron, for carbon it will have 4, and for nitrogen it should have 5. So we're going to be playing around with 10 valence electrons so that we can make bonds and also generate lone pairs. So the next step here is that we need to place carbon at the center. Why is that the case? Because usually the atom that's at the center has the lowest electronegativity value. There are some exceptions to the rule, but in this case, we're going to stick with it that way. Look at the neutrality based on the number of bonds that they can accomplish. In this case, for hydrogen, we know that only one bond is only generated and there are no lone pairs on the hydrogen for it to be neutral. So there we have it. We have our first bond. That means we've used 2 electrons. That means this here, we're going to be left with 8 electrons. And carbon should have 4 bonds around it. So in this case, we should have 1, 2, 3. But this 3 here is going to be shared with the nitrogen. And so in here, carbon should have 4 bonds to be neutral. In this case, 1, 2, 3, 4. We're good with that. And for nitrogen here, we should have 3 bonds with what? A lone pair. And this lone pair here allows nitrogen here to be neutral in a molecule. And so in here we have what? We have our 6 and we have 8 electrons, and this is equal to 0. Therefore, we've successfully generated our what? Lewis structure for this particular molecule. If you want to go into the next stage of this particular one, which is in terms of polarity, we can say that because this side is a little bit more electronegative, let's put it that way. So that means here we're going to have a direction arrow pointing in this direction, a polarity arrow, and we're going to have a partial positive charge and a partial negative charge here. Here, one of the interesting things about this acid is that it tends to lose the proton and ends up becoming something like this. You have a proton and you have your particular molecule. But take note here that in here we have our negative charge that is right here. But take note that this negative charge is going to be somewhere more on the carbon in this case here, so that in this particular case we got cyanide, which is really a toxic, evil ion in here. See you for more chemistry hints here on this particular channel.